today is gonna be the day that they're gonna throw it back to you. By now you should have somehow realized what you gotta do. I don't believe that anybody feels the way I do about you now.
First, we read and analyzed the problem.
The word is on the street that the fire in your heart is out. I'm sure.
Identify variables and formulas.
I don't believe that anybody feels the way I do about you now.
Sketch and substitute the values in the formula.
And all the roads we have to walk are winding, and all the lights that lead us there are blinding.
Obtain the results and analyze them to be coherent with the problem.
Would like to say to you, but I don't know how.
Check our grammar and flowchart.
You're gonna be the one that saves me.
Investigate theory and make conclusions.
What's going on?
It's because I'm explaining to them that if you change the rate of change of one side of a square, also the rate of change of the area, and the perimeter is going to change. It's going to be different.
No, it's only going to change the perimeter.
No, obviously anything is going to change.
Everything is going to change. Why do you say that?
Because
It's magic.
Look. Let me explain with this square, okay?
Okay.
Like, if we have one side and it's growing 1.5 millimeters each hour, obviously the area and the perimeter is going to change. Even better, friend. I'm going to explain you with differentials. Okay, so in reality, this is really easy. I'm going to give you an example with this problem. The sides of a square are increasing at a rate of 1.5 millimeters each hour. At what rate are the area and perimeter increasing at the instant that one side is 28 millimeters? Okay, so look, we have our data. Our constant rate of change, or velocity, is 1.5 millimeters each hour. Our sides, in this case, are 28 millimeters. Our area, the formula for the area is L squared, and the derivative is 2L, and the formula for the perimeter is 4L, and the derivative is just 4. So to obtain the rate of change in the perimeter, it's easy. We just use the information we have. In this case, we already have the rate of change for each side, which is 1.5, and we multiply that times the derivative of that formula. So in this case, substituting is just 4 times 1.5, which gives us a rate of change of 6 millimeters each hour. And for the area, it's just the same, but with the other formula. So in this case, it's going to be 2L times our rate of change for each side, which would be 2 times 28 times 1.5, which gives us a rate of change of 24 millimeters squared each hour. It's important to note that to obtain all these answers, we need to take into account the time. And that's why we have the differential of perimeter, or of each side, or of the area, over the differential of time.
This project helped us notice the uses of related rates of change using differentiation, and we discovered that we have to use that in our daily life. For example, in chemistry, to calculate the rate of change of a chemical reaction, and also in the electricity bill, to calculate the electricity consumed in our household.